Welcome to Liverpool. My name is Carsten Welch and I'm the head of the physics department here and also leader of the OMA, AVA and LiftDOT projects. I'm very delighted to have all of you here in Liverpool, which brings together a number of schools from the city and the region, as well as researchers from all across Europe. We are also live connected to research facilities all across Europe, like CERN, like GSI in Germany. And what we want to do today is we want to have a look at the many different applications that are enabled by particle accelerators. So in my brief introduction, I would like to talk a little bit about the motivation for this event, starting with why fundamental research. Fundamental research is absolutely key for humanity to advance. It drives knowledge, it drives innovation, and without that important question, why, that I'm sure all of you have asked since you are small children, we wouldn't make any advancement in knowledge and as a society. In terms of taking you to different places today, we're going to take you on a journey, and first journey is going to take us to the world's largest particle accelerator, which is close to Geneva in Switzerland at a research organization called CERN. So CERN is a very, very large research organization, and the biggest accelerator that they use to accelerate particles very close to the speed of light is called the Large Hadron Collider, and is a ginormous underground installation, 27 kilometers in circumference. What you can see here on that satellite image is the aerial view of the facility. On the right-hand side, the dark blue, that's Lake Geneva. You can see Geneva Airport stretching at the bottom right, and that big white circle, that's the Large Hadron Collider, where in 4 different places particles collide. So what happens in such a machine? Well, you start with a bottle of hydrogen and you ionize that gas. You then apply an electric field to accelerate the gas out of that bottle of hydrogen, and you bring it first into a linear accelerator before it enters into several circular accelerators. Every single one has the one purpose to increase the energy of the particle beam, bring it closer and closer to the speed of light. And similar to the gear changes in a car, that can't be done in just one go, so you need to change gear, you need to change accelerator on the way through the PS, the SPS, and ultimately the Large Hadron Collider storage rings. And you can see there's many different elements in these storage rings, and you will hear today about what comprises an accelerators and how scientists and engineers can bring these beams to the speed of light and then use them for collisions. These collisions are analyzed in big underground detectors, like the one shown here. It's called compact muon solenoid, but really it's not compact at all. It has the size of a cathedral and requires a large international collaboration to be set up. Now what these detectors create is a big amount of data, and this data needs to be handled somehow. So what we're going to look into today is how is big data influencing fundamental research, but also society as a whole. So how does data influence all of you? The way that we are addressing this here in Liverpool is through a Center for Doctoral Training, and that brings us to the different projects that are organizing the event. LiftDOT at the moment trains 25 PhD students, all in the area of big data science. And they are looking into particle physics, nuclear science, condensed matter physics, astrophysics, all modern areas of physics with a single bridge between them that is data science. Now, once you have these particle beams, you can also look into what else can you use them for other than fundamental research. So what applications are enabled by charged particle beams? And one of our projects called OMA, Optimization of Medical Accelerators, uses particle beams to treat cancer. Now, what you'll see in this short movie is that the facility to do exactly that is very, very similar to what you've just seen before. Again, you start from a simple ion source. You bring your particle beam to higher energies, first in a circular accelerator. You then go through a beam transfer line, which is again very similar to what you've seen just before. But now you're entering a clinical facility, a hospital, not a research center. And in that facility, you have different patient treatment rooms shown here. And you can see that scanning device, which can move around the patient. And what you do is you take these particle beams and you take them to treat cancer in the body of the patient. And today we look exactly into how that's done, what are the most advanced technologies, and in particular, what does that mean for science and research that's done here in the UK and with international partners. What you can also do with particle beams is you can create exotic particles. So shown here is a beam of protons as it impinges on a metal target, and what then happens is that it creates antiparticles, antimatter. And that's really exciting because antimatter doesn't naturally occur in the universe around us, so we can do studies into the comparison between antimatter and matter particles. And that's going to be the following talk that looks specifically into the antimatter universe and how these exotic particles can take us all the way back to the Big Bang itself. And the facilities where this research is done, again, there's one at CERN in Switzerland, shown here, and that's where these particles are slowed down to very, very low energies and used for fundamental studies. And today you will find out what these studies can tell us. The project that's behind this, from our perspective, is a project called AVA, Accelerators Validating Antimatter Physics. Again, the researchers in this network, they are here today. They will present their research later, and they are open for questions. And they also have prepared exciting experiments that you can join here during the day. Now, finally, in order to drive innovation, we need science, we need engineering, but what's also important, we need creative subjects. So we need creativity, we need new ideas, we need interesting designs. And our final talk of the morning will look into exactly that. So how should science and the creative subjects work together to boost innovation together? Now, hopefully an exciting program. I'm very much looking forward to the different talks. And before handing over to Selina, who is going to introduce the different speakers, I would like to invite all of you to help us share the experiences of today. Take photographs now during the talks, but also later during the hands-on activities, and use Instagram, Snapchat, where we have a special geo-filter today, or Twitter. Tag us via LiveUniPhysics and the hashtag ACC_SCISOC, and send us your photographs, your messages, and the best post of today will also win a prize later on. So enjoy the day, be curious. You get the opportunity to ask questions after each talk, or you can also tweet these questions, and learn everything about accelerators. Thank you very much.